Welcome back to the Deep Dive, where we sift through the avalanche of weekly Azure updates so you don't have to. This week, covering November 10th through the 14th, 2025, the signal is, well, it's deafening. If you are running large-scale, high-performance container environments, this deep dive is basically your immediate roadmap planning session.
That's absolutely right. You can really see a distinct strategic commitment from Azure this week. It's heavily weighted toward refining Azure Kubernetes Service AKS networking and foundational platform security.
So we're seeing some major architectural shifts.
We are. Some are now production ready, others are still in the testing channel, but organizations running distributed cloud-native workloads, they need to be budgeting and planning for these right now.
Okay, so that's our mission today, synthesize these updates.
Exactly. The new performance enhancers, the governance tools, and critically, the deadlines that are now looming in 2026.
Right, we'll definitely get to those deadlines and the general availability features like .NET 10 a little later on. But I agree, we have to start where the volume of innovation is highest.
The Kubernetes ecosystem.
The Kubernetes ecosystem. We're talking low-level networking optimization and even AI-assisted diagnostics. Let's kick off with performance and scale. For organizations leveraging the Azure CNI Overlay model, one of the biggest constraints we always hear about is IP exhaustion.
Oh, always. It's a constant headache.
Well, we now have a public preview for pod CIDR expansion in Azure CNI Overlay for AKS.
And this is a massive quality of life improvement for cluster operators. I mean, historically, as dynamic clusters scale up and down, you have thousands of pods just coming and going. Running out of assignable IP space for those pods is a constant operational fire drill.
Right.
By enabling this expansion, Microsoft is ensuring the underlying network fabric can truly support those hyperscale environments without, hitting that frustrating arbitrary feeling. It's crucial.
And speaking of optimizing the fabric, there's a public preview that gets way down into the technical weeds. I'm talking about data path efficiency. eBPF host routing and advanced container networking services for AKS. Now, for listeners who aren't, steeped in Linux kernel optimization, what exactly is eBPF bringing to the table here?
It's a fundamental performance shift. It really is. Traditional container networking relies heavily on the Linux kernel's networking stack, which, it introduces latency and processing overhead, especially as traffic bounces across nodes.
So it's like a tax on performance.
Exactly. A container networking tax,
Yeah.
eBPF, or Extended Berkeley Packet Filter, lets us essentially bypass large parts of that traditional stack. It ejects these small programs directly into the kernel for ultra-efficient, highly customized host routing.
Okay, so you get better throughput, lower latency.
Significantly lower latency,
Yeah.
especially for those Azure CNI-powered clusters. It's a big deal.
That does sound highly technical. Let's shift to something that maybe directly impacts daily operations. DNS. Local DNS for AKS is now generally available. What makes this such an immediate win for the people managing these massive clusters?
Operational stability. Pure and simple. In large Kubernetes clusters, you have services constantly communicating, and every single piece of that communication relies on reliable DNS resolution.
And if it fails, everything fails.
Pretty much. High query volumes or even minor upstream DNS outages can trigger these cascading failures across the entire cluster. Local DNS acts as a local cache and resolution point. It dramatically speeds up resolution times and, more importantly, it provides resilience against those external issues. If you've ever debugged an obscure service failure caused by intermittent DNS timeouts, you know why this move to GA is a blessing.
I think we've all been there. Okay, so moving from performance to security, we have two different but equally important OS-level public previews for AKS nodes. First up, Azure Linux OS Guard for AKS.
This is a direct response to the evolution of cloud-native attacks. Specifically, we're talking about those targeting the host operating system.
Things like rootkits and container escapes.
Exactly. OS Guard is designed to tackle those sophisticated low-level threats. It provides these hardened security guarantees at the Azure Linux node level, making it significantly harder for an attacker who breaches a container to then pivot to the underlying host.
And relatedly, Flatcar Container Linux for AKS is also in public preview. This seems less about attack mitigation and more about, say, operational hardening and maintenance. Is that right?
That's a great way to put it. Flatcar is designed to solve operational debt. When you run large fleets of nodes, you get this thing called configuration drift, where node settings just subtly diverge over time. It becomes a major headache.
And a security risk.
A huge security and consistency risk. Flatcar uses an immutable OS image. So it reduces the attack surface and ensures that consistency, because nodes only ever boot into known secure configurations, It drastically simplifies the upgrade and maintenance path. It's all about reducing that operational friction of scale.
Before we wrap up the AKS stack, let's look at the future of management. We saw the public preview of the scheduler profile configuration for AKS.
Right. If you are running anything beyond simple web apps, think HPC, AI training jobs, complex data pipelines, you can't just rely on the default scheduling logic.
You need more control.
You need a lot more control. This new configuration lets you dictate your scheduling goals. So whether you prioritize lowest cost, max performance, or specific resource affinity, you can now tune the scheduler to meet those complex workload requirements.
And then there's the inevitable integration of AI into operations. The agentic CLI for AKS in preview. I have to ask, using AI to debug Kubernetes sounds fantastic on a slide. But in practice, relying on an AI black box for root cause analysis can be a little terrifying.
That is the critical challenge, isn't it? I think the real takeaway here is that Microsoft is treating the CLI itself as an interface layer for the broader AI Copilot ecosystem. It's not just searching logs, it's correlating telemetry and recommending actionable resolutions. It's leveraging knowledge graphs derived from years of Azure support cases.
So the goal is to cut down on mean time to resolution.
Exactly. By handling that initial time-consuming slog of sifting through logs, it allows the engineer to validate a diagnosis rather than having to discover it from scratch. It augments the skill set.
Okay, that covers a ton on the container side. Now let's move across the platform to GA features focused on hardening the network perimeter and increasing governance, starting with Azure Virtual Network Manager, or VNM. For listeners who may not use VNM daily, just a quick reminder of its primary function.
Sure. VNM is the centralized control plane for managing connectivity and security across large distributed network estates. Think complex, hybrid, or multi-region enterprise networks.
It's all about consistent policy enforcement.
That's it. And this week we saw 3 key features hit GA at the same time, all addressing large-scale governance and automation.
Okay, what are they?
First, the UseExisting mode for UDR management is now GA. So if you're a large organization with complex compliance rules, you often have existing user-defined routes, UDRs. This mode allows VNM to detect those existing routes and then safely append or enforce the routes VNM requires.
Avoiding route conflicts.
Avoiding conflicts and providing that essential flexibility for maintaining compliance.
And the second feature helps with scaling out IP structure.
That's the IP Address Management Pool Association recommendation reaching GA. For expanding networks, manual IPM gets messy and error-prone very, very quickly. This GA feature brings intelligent automation to the IP space, generating recommendations to ensure efficient, non-conflicting use of addresses across massive growing VNet estates.
So it automates a tedious process.
A very tedious, human-intensive process.
Yeah.
And the third VNM feature is purely a security and governance gate, VNM peering compliance.
And this does what?
It's an enforcement mechanism. In massive network environments, it's just too easy for engineers to inadvertently establish unintended or non-compliant connections between virtual networks. Peering compliance provides the central governance to prevent those from ever being established. It enforces your segmentation strategy right at the VNet level.
Got it. Moving now to firewall and WAF enhancements, which seem heavily focused on visibility. First, DNS flow trace logs for Azure Firewall are GA.
Yes, and security teams crave this kind of visibility, especially for DNS traffic. This new logging capability provides rich, end-to-end telemetry into how DNS packets flow and are resolved through the firewall. If a policy is blocked or misconfigured, having that detailed trace log is indispensable for rapid validation.
We also saw the GA of using packet capture to troubleshoot Azure Firewall.
This is one of those debugging features engineers have requested for years. You can now capture specific flows in the firewall, filter them by protocol flags, source, destination.
All through the portal or PowerShell.
Exactly. The ability to capture those transient flows is so much more effective for a deep investigation than just relying on aggregated logs.
Okay, finally, the WA improvements. We saw Azure WAF JavaScript challenge on Azure Front Door hit GA.
This significantly strengthens bot mitigation. The JS challenge adds a layer of client-side verification that helps distinguish sophisticated malicious bots from legitimate users. It's an essential upgrade to your bot defense strategy.
And connecting back to our container conversation, Application Gateway for Containers with Web Application Firewall, WA support is now GA.
Right. Application Gateway for Containers is the evolution of the Application Gateway Ingress controller. Bringing WAF support to this modern platform means you can now protect your containerized apps with robust enterprise-grade WAF capabilities right at the gateway.
We've now hit section 3, and this is where technical planning moves from performance gains to hard deadlines. We have to start with the retirements that require action planning for 2026. The retirement of support for Python 3.10 ends on October 1st, 2026.
This is a critical date for developers using app service.
Yeah.
And let's be clear, while Python 3.10 apps will continue to run after that date, the key phrase is loss of support.
Meaning no more security updates.
No security updates and no customer service support for those apps. For compliance and security audits, organizations must factor in migration and testing time to move to a newer, supported Python version well ahead of that deadline. This isn't a small task.
No, it requires full audit cycles and regression testing. Similarly, there's a retirement date for container users leveraging hybrid cloud. Windows Server 2022 on Azure Kubernetes service, enabled by Azure Arc, is also retiring in October 2026.
That's another hard deadline impacting organizations managing hybrid fleets. If you have Windows worker nodes running via Arc, you need to factor in an upgrade path or a migration strategy for those nodes before support ends. Ignoring these deadlines introduces, well, serious security and operational risk.
Okay, on a more positive note for modernization cycles, .NET 10 is generally available.
Yes, this is the anchor developer release for the year. .NET 10 is designed to be faster, more secure, and more capable. It includes the latest refinements from C# 14. This GA release is really the catalyst for immediate application modernization projects across the enterprise.
And finally, a couple of excellent GA updates for Azure Database for MySQL Flexible Server. First, triggers for Azure Functions.
This is a huge win for developing modern, event-driven applications on MySQL. You can now set up change tracking to automatically trigger an Azure function based on a row creation, update, or deletion. It lets you build reactive applications without that messy, latency-inducing requirement of constantly polling the database.
And the second MySQL update addresses a really specific migration need: server parameter support for lowercase table names.
This is a highly requested feature, particularly for migrations from MySQL version 8.0 plus entry. Being able to self-serve configure this lowercase datable names parameter during server creation, it just addresses common compatibility challenges. That kind of configuration parity is often the most frustrating hurdle during a database migration, and this removes that friction.
Okay, to wrap up, let's look at updates addressing data resilience and proactive security during migration. For massive data lakes, vaulted backup for Azure Data Lake Storage, ADLS Gen 2, is now GA.
This is a critical resilience feature. Vaulted backups ensure you maintain an independent, isolated, and offsite copy of your data separate from the source account.
Which is key for ransomware protection.
Paramount. For ransomware, for accidental deletion, for compliance. It's basically an air gap for your data leak.
And for high-performance storage replication, Azure Blob Storage saw 2 priority replication features hit GA. First, object replication, priority replication.
This just allows you to obtain a prioritized replication process with an associated service level objective, an SLO. For mission-critical data, you can guarantee replication completes faster than for non-critical assets.
And relatedly, geo-priority replication is GA for GRS and GZRS accounts. Just remind us of the difference between GRS and GZRS and why priority matters here.
Sure. So both GRS and GZRS replicate data to a secondary region hundreds of miles away. GZRS adds high availability by also replicating across availability zones within both regions. This geo-priority feature accelerates that replication, and it's backed by an SLA that guarantees an improved last sync time. If you rely on low recovery point objectives RPOs for your DR plans, accelerating that inter-region replication is crucial.
Finally, a public preview focused on shifting security left. Integrated security insights in Azure Migrate.
Right, this is all about proactive security assessment. Before you even move those on-premises workloads, Azure Migrate is now offering actionable recommendations to assess and mitigate risks in your source environment.
So you fix the problems before they ever get to the cloud.
You identify and remediate security gaps as part of the initial planning phase, so those risks don't follow the workload into the cloud.
So this week was fundamentally about control and next-generation infrastructure. It's about bringing serious operational discipline to the container and networking space.
Indeed. The concentration of public previews we talked about in AKS networking and security, it strongly suggests the immediate technical roadmap for high-performance cloud-native infrastructure. Engineers planning their 2026 cluster updates should be investigating these previews now.
Absolutely. So here's a final provocative thought for you to consider this week. Given the general availability of .NET 10 and the hard retirement timelines announced for Python 3.0, how does the release and support cycle of your chosen runtime stack factor into your organization's mandatory 2-year cloud modernization plan? If you're relying on a legacy, unsupported runtime, that October 2026 deadline will arrive a lot sooner than you think. Thank you for tuning into the deep dive, and we'll catch you next time.